This video goes over a variety of questions on parametric equations and implicit differentiation from C4. The questions are from a mixture of exam boards, and they were sat by Havant Sixth Form college students in December 2016. So this is a little bit of feedback. First question, implicit differentiation. Let's just go over that. If we look at this equation here, we're going to differentiate both sides with respect to x. Now, any term in x, it's clear. That's the 2x squared differentiated is obviously going to be 4x. But this bit here is actually a product. So differentiating that, we're going to differentiate the two bits separately. So if I've got a 5x, which differentiates to 5 times by y, and I've got a y, which differentiates to dy by dx times by 5x. I've bracketed it because it's quite a common error that I saw in marking our work to actually get an incorrect sign here moving forward. And then this bit, obviously, we're differentiating with respect to y, with respect to x, pardon me, which is 2y dy by dx. We basically differentiate it with respect to y, which is 2y, and then times by dy by dx. Now 9 obviously is a constant, so that differentiates to 0, and so does 0. Right, now at this point you might be tempted to rearrange, most students did, and just get an expression for dy by dx, which is fine. It really doesn't make much difference here. However, if the question had asked for a maximum or minimum, we definitely would have been better off subbing in at this point, because it would have taken this out and this out. Okay, so, but in this case, I'm going to sub dy by dx in now. I don't think it makes a lot of difference. So dy by dx is equal to 3 over 8, because it tells us that in the question. Each has a gradient of 3 over 8. So we have 4x minus 5y minus 5x times by 3 over 8 plus 2y times by 3 over 8 equals 0. Right, so that gives me, if I times out the top, I get 4x minus 5y minus 15x over 8 plus, I can might as well multiply at the top, 6y over 8 equals 0. Right, now if I times through by 8 at this point, I'm going to get, so if I times by 8 at this point, I'm going to get 32x minus 40y minus 15x plus 6y equals 0. So I get 17x equals to 34y, which gives us what we want, x equals 2y divided by 17 as required. Okay, a lot of people, as I say, got the expression for dy by dx and then put in 3 over 8. It shouldn't make much difference here. Okay, in the second part, it says, hence find the coordinates of P and Q. Now we really want to be subbing back into here now, this back into here. Okay, because we've got x equals 2y and we want to sub that back in. So 2x squared minus 5x, oh no, we're substituting for x. We'll make it easy, won't it? So let's just do 2 times 2y squared minus 5x times, I'm doing it again, 5 times 2y times y plus y squared plus 9 equals 0. So that gives me 8y squared minus 10y plus y squared plus 9 equals 0. That then breaks down to y squared equals 9, which gives me y equals plus or minus 3. Now, a few people slipped up here. They went the wrong way when they were subbing back into x. Some even use this expression. We really are going to get some solutions there which aren't solutions, which don't have a gradient of 3/8. That's the problem with that one. We want ones which are definitely on the curve and have coordinates 3/8. By subbing it into here, we know that it's on the curve, and therefore, but we now being subbing into there, we now know it's got 3/8 gradient 3/8. So we can just put x back into there. So x is double y, so that's 6 and minus 6. So our 2 points are 3, 6. You can call them P. Q is fairly arbitrary. Which way we go with that? 3 and minus 3 and minus 6. Okay, that's that question done. Let's go on to the next question, which is a parametric equation question. So this question is parametric. We want to find dy by dx. So let's find dy by dt and dx by dt first. Dy by dt of this expression here, well, obviously the minus 4 goes, and that is, we're going to be timesing by the minus 2 there. So that will be minus 16 e to the minus 2t, and that's dx by dt. So let's say dx by dt is that. Dy by dt, similar type of thing. We've got a 2t as our exponent, so we're timesing by the 2. So that's equal to 4 e to the 2t. So that's that, and of course the 4 goes. Now dy by dx, it's basically a chain rule, but with parametrics, I just prefer to write it like this. Okay, so we've got dy by dt over dx by dt. So that's 4 e to the 2t over minus 16 e to the minus 2t. This is where a few students did slip up. It's 4 over 16, which is minus 1/4, or with the negative with it. And e to the minus 2t on the top would be positive on the, so minus 2t on the bottom would be positive on the top. All of indices e to 4t. Makes it going to be, if I use this, it's going to make it easier in the next bit to get it right. Right, so that's part A done. So on B1, we want the gradient, so it's just a matter of subbing ln2 into this expression here. Okay, so we have dy by dx when t is equal to ln2 will be equal to minus 1/4 e to the 4 ln2. I'm not going to use a calculator, but I'm sure most of you did. That's e to the ln 8, or not ln 8, ln 16, because if I take 2 to the power 4 using the rule of logs there, I get 16. So e ln 16 by definition is 16, minus 1/4 of that is minus 4. Okay. Right, then the second part, the coordinates of P, well, that's just a case of subbing it back into there. So x coordinate is equal to 8 e to the minus 2 ln 2 minus 4. I'm doubly not going to use a calculator still. That's 8 e to the, because I'm going to take the minus 2 as exponent on that top, so that's t to the minus 2, which is ln 4, ln a quarter, minus 4. E to the ln quarter by definition is a quarter, so that's equal to 8 divided by 4 minus 4, which is equal to minus 2. And the y coordinate is equal to, I'm going to put in this one, 2e to the 2 ln 2 plus 4, which is equal to 2e to the ln 4 plus 4. E to ln 4 is 4, that's times by 2, which is 8, plus 4, which is 12. Okay, I didn't use a calculator, but of course you were allowed to. Okay, and that leaves for part 3. A few people, actually, it's good to read the question. It only wants the normal crosses the axis at, find the coordinates of Q, that it crosses the axis at Q. It doesn't ask for the normal, it just wants where the normal crosses the axis. So we can save a bit of time. You'll see what I mean in a moment. So 1, 2, 3, there we go. Let's just do it up here. So the gradient of the normal crosses. So the gradient of the normal at this point P will be negative the reciprocal of this. So it's basically, because we've got minus 4 there, that will be equal to a quarter. So then we can use y minus y1 equals mx minus x1. It's all set up for us because we've been asked to find the x and y coordinate in part 2 here. So we can do y minus 12 is equal to a quarter x minus, or plus 2, x plus 2. Now we steal a bit of time here because you might be tempted to just go on and rearrange. But in fact, we already know that it crosses the x-axis when y equals 0. So we're actually solving minus 12 is equal to a quarter x plus 2. So we can multiply out. So that's minus 48 equals x plus 2. So x equals to minus 50. Better write it as a coordinate. So that's minus 50, 0. Okay. Okay, so on to part C. Various approaches people did. Some actually just put into this form, which I suppose is acceptable, not what we really expected, and then found a value of k. Well, I gave 4 marks for that, but didn't see it in the mark scheme, but I think it'd be okay. Some use logs unnecessarily, although it's possible. I think the best thing to look at, the first thing that occurs to me, is these are very similar forms. We've basically got e to the 2t in both of these expressions. So if we just isolate e to the 2t and then say sub for it, then it should be okay. So let's look at x equals 8 over e to the 2t minus 4. So that gives me 8 e to the 2t is equal to x plus 4. So we can then flip that over. So e to the 2t over 8 is equal to 1 over x plus 4. So e to the 2t is equal to 8 over x plus 4. Okay, and then if we do a similar thing to the other one, to this one, we've got y minus 4 equals 2e to the 2t. So e to the 2t is equal to y minus 4 over 2. So we can just equate these two. So sub for et or equate or whatever. So sub, we've got 8 over x plus 4 equals y minus 4 over 2. Okay. That then we just need to multiply out, but be careful, a few people made mistakes here. That gives me 16 is equal to x plus 4, y minus 4, and we know where we're heading here, okay? But a few people rushed it here at this point and thought, oh joy, I've got there, and just wrote k as 16, and it's not, because when we multiply this out, we get xy minus 4x plus 4y, but we also get minus 16. So that means that we can say, swapping it around a bit, xy minus 4x plus 4y equals 32. Okay, so that's that question done, and we're ready to get on to the next question. So question 3 is another parametric equation question. I'd say probably the one done the worst probably on average, although it's a bit of a mix really. Yeah, let's just do the differentiating bit separately. dy by d theta is equal to 6 cos 2 theta. It's sine differentiates to cos, but because of the 2 theta, it's basically a basic case of chain rule. That's 6 cos 2 theta. And then dx by d theta equals to minus 2 sine theta. So dy by d theta, which is what we're trying to, dy by dx, okay, is equal to dy by d theta over dx by d theta, which is equal to 6 cos 2 theta over minus 2 sine theta. Let's deal with the minus 2 first and all that stuff first. So that's just minus 3 cos 2 theta over sine theta. Now it's clearly not in the way they want it, because they say so that it's equal to this, so we've got a bit more work to do. Well, obviously we've got double angles to work on. Now, because there's a sine and a cosec there, we know that really we want sines in our the sine ratio rather than the cos ratio. So I'm going to replace the top bit with 1 minus 2 sine squared theta over sine theta. So multiplying that out, that gives me minus 3 sine theta plus 6 sine squared theta okay, all over sine theta. Right, it's not 3 sine theta, of course, it's just 3. Minus 3 plus 6 sine squared theta. Now, that equals minus 3, if we write that out this way, that's minus 3 over sine theta plus 6 sine squared theta over sine theta. If I swap that around a bit, I get the sine squared over sine, obviously it cancels down to sine. So that's 6 sine theta minus 3 cosec theta. Okay, and that's that question done. 4 marks. Okay. Right, the next part 2, is find the gradient of the normal. It doesn't want the equation, just the gradient. So we're subbing in pi by 6 first of all. So dy by dx when theta equals pi by 6 is equal to 6 sine pi by 6, okay, over minus 3 over sine pi by 6. Okay, now sine pi by 6 is equal to the square root of Sine pi by 6 is equal to half, of course. So that's 6 sine a half. So that bit's half. So it's 6 times a half minus 3 over half. So that's equal to 3 minus 6, which is equal to minus 3. But that's the gradient of the tangent. So that means the gradient of the normal is 1/3. Okay, thanks. Right, okay, next bit, part B. Okay, on this part, it seems to me that because we've got a y squared, it may be a good idea to square our expression for y and work with that. A lot of people did that. So we've got y squared is equal to 9 sine squared 2 theta, and that equals to 9 times 2 sine double angle formally, sine theta cos theta squared. So that equals to 2 squared, which is 4. So that's 36 sine squared theta cos squared theta. All right, well, that's quite promising because we can obviously get an expression for cos theta from that, because we know that cos squared theta is x squared over 4. But before I do that, what I'm going to do is just write this as 36 1 minus cos squared theta over times cos squared theta, and that means I can then work a sub for that, but x over 2 equals cos theta, so that gives me, I can sub cos squared theta is equal to x squared over 4. So that means subbing x squared over 4 back into these expressions, we get y squared is equal to 36 1 minus x squared over 4, x squared over 4. A lot of people got to this far, which is good, then made little errors here from this point on. So that's y squared equals 36, let's put over common denominator, 4 minus x squared over 4, x squared over 4. Now we're over 2 4's here, so basically that's 36 4 times 4, if you like, on the bottom there, 4 minus x squared, x squared. Right, now I wouldn't really write that because 36 over 4 is 9, so one of them will go like that, so that becomes 9 over 4. Right, okay, so that is question 3 done. Let's have a look at question 4. Okay, so this is implicit differentiation again. We're going to differentiate this expression with respect to x. So any x terms fine, any y you just have to put on a dy by dx to work with, so that you're differentiating it with respect to x. That's 2 dy by dx. We're using the product rule on this bit. So that will be, if we differentiate the e to the 2x bit, that comes to 2e to the 2x. So that's 2e to the 2x times by the other bit, which is y squared. Right, that's product rule though. Then, that's only one of the terms. In that one we differentiated the e to the 2x and then we multiplied by that. Then we do it the other way around, add it, and we need to times by y squared differentiated, which is 2y times by dy by dx, because the term is y, and then we need to times that by e to the 2x. Tell you what, I'll shove the e to the 2x just afterwards like that. Okay, so that's product rule for that, and then we just have that equals to 2x. Oh, I've missed out part A, haven't I? Oh, never mind, we'll do that in a second. Get back to part A. I'm doing part B at the moment. Right, okay, so now I just need to rearrange, really. It's not too bad. One thing I would do is knock off the 2 at this stage. 2 is in everything, so divide by 2. Okay, so we have dy by dx, take the terms in dy by dx on one side, that's plus y e to the 2x dy by dx is equal to x minus e to the 2x y squared. Then factorise the expression dy by dx 1 plus y e to the 2x is equal to x minus e to the 2x y squared. So we have dy by dx is equal to x minus e to the 2x y squared over 1 plus y e to the 2x. Okay, and that is that question now done. Now apologies, I missed out part A, just so as you be careful when you look at a paper that you actually read the questions. And so we'll do part A now up here. It's just only one mark here. It says find the exact value. We're told this point on the curve, so we just have to sub in 1 and 1 over e to the x. So sorry, 1 over e. So we've got 2 times 1 over e plus e to the 2, because x is equal to 1, times 1 over e squared is equal to 1 squared plus c, and that becomes 2 over e plus, and this becomes e squared over e squared, which is equal to 1. That's equal to 1 plus c, so the 1 cancels and we have c is equal to 2 over e. Okay, then do part C. Verify that this is a stationary point. Now, if the word verify is ever used, that means we can work forwards and just put that number into this expression here. And it's actually only really the top we need to consider. So at P we have dy by dx equals to 1 minus e to the 2 times 1 times 1 over e squared. It's almost irrelevant what the bottom is, but I'll write it out anyway. 1 plus 1 over e times by e to the 2, but it actually doesn't matter because it's the top is going to be equal to, so it's 0 over something, so that equals to 0, so that shows that there is a stationary point. Okay, on to the last question, question 5. Right, okay, this is parametric integration. It's basically asking us for the area of this whole loop. If you do, some people converted to Cartesian, which is possible. Bear in mind, if you do that we've got 2 branches here, there. This branch here, the bit that goes from there to there, will actually have equation y equals to, because you'll be effectively getting minus t from that equation. So when you're subbing it back in, minus x into that equation when you're subbing it back in, so that'll be minus x to the 3 over 2, and then plus x to the half. That would be that term there we'd have, and this bit here would be y equals to x to the 3 over 2 minus x to the half. Okay, but I thought I was a little bit untidy, so I'm going to use parametric integration. And use the parametric equation here. We have a handy equation for that, but we do need to find the limits. So we need to equate x or y equal to 0. Well, equating x equals to 0 just gets me t equals to 0, which just corresponds to that point. Equating y equals to 0, I get t cubed minus t equals 0. I get t plus 1 and t minus 1 equals 0. And I get t equals 0, which is exactly the same point I've already found here. But I also get two values of t here. T equals to minus 1, t equals to plus 1. And what it corresponds to is the two values of t that come through, one coming through that way, and that they're both the same coordinate, but one corresponds to when it's coming that way, and the other one when it's coming that way. We could work out which one's which, but to be honest, if I integrate between 1 and 0, I am actually going to be working out the bottom area here, but it wouldn't matter if you worked out it wouldn't matter terribly. You just need to consider the sign of it and just modulate it if it comes out the wrong sign. So I'm going to integrate between 1 and 0 for the value of t. Okay, and that will get me one side of the graph. It will happen to be that side, and the reason is because if you look at our positive values for t, it's on the bottom bit here. Okay, so that's why it comes out negative, but it doesn't matter. We can just double the answer at the end. And there is a formula for, let's write the formula out before I get to this actually. The formula is integral y dx by dt dt. Okay, so yeah, so we've got y, which is t cubed minus t, times by dx by dt, which is 2t dt. Let's multiply that out. 1 to 0, that's t to the 2t to the 4 minus 2t squared dt. That, let's write it up here, equals to, integrate to the 2 bits, that's 2, adding 1 to the power, that's 5, so it's 2t to the 5 minus 2/3 t cubed. Okay, and that is now between 1 and 0. So if I put in the values 1 in now, obviously you just get 2/5 minus 2/3 will be the answer, because the other one's 0, and that comes to actually -4/15 for the reason I said, because for the positive values of t, we're actually below the axis, so don't worry about it. We'll just make it positive and double it. So the required area is equal to 2 times 4/15. 8/15 is the required area. Incidentally, I had a few people ask me what if they use actually did -1 to 0. Okay, and they wondered why the answer still came out negative, even though it was actually corresponded to the top of the graph. And the reason is, as we increase our value of x here, our value of t is decreasing, so the limits are almost the wrong way around. We'd almost have to do a strange thing where we have the upper limit above the upper limit being lower than the lower limit, like that, which is a bit strange, but it's a bit confusing. So that's why I did the bottom bit. It doesn't really matter. It would come out as if you get a negative, you just take it off and then double the answer, because we know by symmetry it'll be equal to the same as that. Okay, had anyone integrated between 1 and minus 1, I didn't see this at all. In fact, you'd have ended up with the answer minus 8 over 15, which might have been a bit strange, but then as long as you drop the negative, it would still be correct. Okay, so that's that done, and yeah, hopefully you found this video useful. 35 minutes for 45 marks with all the waffling I've done isn't too bad. Okay, bye.